Okay, I want to talk about exponential growth and decay. A lot of physical processes and biological processes are modeled through the use of exponential functions. And so y is equal to y naught times, let me try this again. Y is equal to y naught e to the kx. Sometimes you'll see this written as, y naught e to the rt. Stuff like, depending on whether you're using x as your variable or t as your variable, k and r are both going to be constants here. These represent exponential growth and decay. If k or r are positive, this is exponential growth. And if k or r are negative, this is exponential decay. And so these things get used. Maybe two of the most common examples for exponential decay is actually the decay of radioactive isotopes of atoms. That if you have some atom that exists as an unstable isotope, it generally decays following an exponential decay law. The most popular example for exponential growth has to do biology-wise, that if you have a colony of bacteria, this is the classic example, growing in a dish, it tends to follow an exponential growth law. And so let's do an example of each of these. So radioactive decay, here I've explicitly made the r, the constant up in here, negative, by saying r is positive, putting a negative sign on here. And so for radioactive decay, so carbon-14 is a radioactive isotope that the use of this is often used to attempt to date how old certain objects are. So in this case, r is 1.2 times 10 to the negative fourth when t is measured in years. How much is left after 866 years? Where here, y naught is the initial amount. So let's just do some calculations with this. And we're thinking of this, y as a function of t here. Y of 0 is y naught e to the minus r times 0. E to the 0 is 1. So y of 0 is just y naught, the initial amount. And this makes sense. When t is equal to 0, how much do you have? Whatever you started with. Nothing's changed. After 866 years, so this would be y of 866, is y naught e to the minus r. R is 1.2 times 10 to the minus 4th. We want to multiply this by 866. And if you take your calculator and crunch out e to the minus 1.2 times 10 to the minus 4th, if you multiply those together and then do e to the resulting thing, you get about 0.901 times y naught. So after 866 years, you're left with about 90% of what you started with. And you're left with about 90% of what you started with, and 10% of it is gone.